Um, I think who was the one who was asking the question? Shiva, right?
Yeah, sure, Prasad.
Okay. We'll be having a tool where we can add all the test cases at once, and we can launch a regression where we can put some count. For example, we have one test case. Each test case we can put some 10 count. So 10 times with different random seeds, it will get a hit, means it will run the test case and it will give us a entire report, like how many test cases are passing and how many test cases are failing. For example, any one of the test cases failing for one particular seed, you can fetch that seed number and run that particular test case in your local and see the particular log and see where exactly the issue is. Either it is some issue with the randomization or some issue with particular seed itself, it is giving an issue, or the other ways it is not catching the issue. Like that, you can again see the waveform and examine the waveform and try to come to a conclusion what is the exact issue. So that is the regression suit.
Oh, we can come to the like how is it related to coverage? This regression
Because
suite.
if you want to see the coverage, so for example,
me
there is a variable, for example, bus speed for I2C, for suppose, let us assume for I2C bus speed. So you have randomized that bus speed. It should be fast or it should be slow, standard, or it should be fast plus. Okay. So if you want to randomize that, then if you through regression suite, if you see, you will be covering all the three possibilities. So your coverage number will increase now because you will have written a coverage bin saying that you want to cover all the speeds: standard speed, fast plus speed. If you don't run a regression only for that particular test case, if you see the coverage, only the standard bin will get hit. The other two bins will not get hit, right? So that is where the regression plays a major role. It will give us an analysis combined report and combined coverage. So that's where your coverage numbers will keep on increasing.
Okay.
Okay. You will understand more if you see how the coverage bins are written, all that, right? So this is at the very initial stage, introduction stage. So further, if you don't get it, you ask me, I will let you know. But for now, this much of knowledge is enough.
Yeah, thank you.
Yes. Actually, Prashanti has asked some question, right?
Yeah, you can go on. It's completed.
Okay, done. Okay, so we have, is there anyone else who have any questions, or can I start? Okay. So in coverage, basically the coverage is for, as I already told, it is a percentage of verification, different objectives which we have, that how we will, how much we will track, that is through the coverage. So in coverage, we have basically two types of coverage. One is the code coverage and the other one is the functional coverage. Okay. When it is coming to the code coverage, the different lines in the design, for example, we have 50 lines of code in the code coverage. Means like in a design. So the code coverage will give us the report like in 50 lines, how many lines are getting exercised, means how many lines are getting hit. So through that, we will understand, okay, this part of the code is not exercised. So I need to provide a stimulus in such a way that stimulus means like inputs. You will in an normal example, if I say, for example, full adder, it is of two inputs, for suppose. The two inputs means 00011011, right? For example, any one of the line it is not getting executed means that particular thing which we wouldn't have given a stimulus. That's why that code coverage is not getting executed. So then you have to go and check your stimulus. Are you providing a proper stimulus or not? Like this, the code coverage will work. So the code coverage will be automatically extracted by the simulator itself. So so through that enabling, if you enable that code coverage, you will be able to see the code coverage report. Based on the report, then again you can go back and do different changes in your test bench, and again you can come back and see the code coverage report. That's how you have to improve the code coverage entirely. for the verification. Okay. And then we will see here I have taken a small snapshot to make you understand how it looks like in code coverage. See, if you see here, it is a green, right? Means this part of the code is got executed, and here it is not executed, and again here it is executed. Like this, you will get a report of the particular code coverage report of any of the design you provide. Okay. Here in code coverage also we have different types of coverage like block coverage, FSM coverage, toggle coverage, statement coverage. For example, block coverage means whether this begin and in this particular begin and block it has been executed or not. All this we'll go through further. But for today, I'm just giving you an intro how exactly it looks and all. Okay. So next, the functional coverage. As I already mentioned, the functional coverage is very important in the our design environment or any of the verification of the design. So basically, the functional coverage gives us, like as I already mentioned, right, a requirement. RS will be given from the designer, right? So whatever different requirements are there, different features are there, how well all the features are executed or exercised or not, this report will be given by the functional coverage. In the name itself, it says, right, functional means the different functionalities of the design are executed or not. So that report will be given by the functional coverage. Okay. So here in functional coverage, we will be writing different kind of bins and the cover groups and the cover points. Through that, we will fetch the functional coverage report. And I have already mentioned, like in functional coverage, if the test is failed, we cannot capture that functional coverage because the functionality itself is failing. It means that whether so we can't capture that functional coverage information. Okay. So here, if you see here, like this, it will show like how much coverage has been done. For example, any of the cover point is not getting hit, then the coverage will not be 100%. Sometimes there could be a chances that it could be 50%. Means any of the bin is going from 0 to 1. There are different kinds of bins as well. Means transition bin means we can write like from 0 to 1 it is happening or not, and from 1 to 0 it is happening or not. So any case where it is happening from toggling from 0 to 1 and it is not happening from 1 to 0, then it will split only 50%. Likewise, that also depends on the width of the variable. The width of the variable is only of 2 bit, means 1 down to 0. It has a possibility of 0 and 1. So in that, if only one case is hitting, it will give us the 50% coverage. Likewise, it will calculate and give the percentage. So that will be entirely taken care by the tool. So we need not think about that. But for information, for having a knowledge, I'm just telling you. Okay. So then it comes the assertions. Usually the assertions can be checked dynamically in the simulation also or the statistically. Do anyone know what are assertions? So I can hear from any one of you if it's possible. What are assertions? Why do we need assertions? Am I audible?
Yes, you are audible.
So, ma'am,
You
assertions are
scared me
basically,
thinking that I was thinking I am not audible. Okay, go on.
ma'am, assertions are basically, I mean, true block of statements. Basically,
Yes, you are audible.
yeah.
Yes.
So, they will have like maybe, in basically what happens is when you happen to write a big block of a code with some functionality,
Hmm.
and you can write it with, a simple an assertion statement or which contains a property,
Mhm.
and that property will be equivalent to a big block of code which you can write in some block of language. So, I mean, in short language, I can say basically that to cut a long story short, we can say that it's a true block of statements that if it is executed, then it is fine. Uh, else it fails. I just have this much of knowledge about it.
Yeah. So you're right, Ankesh. Thank you. So, for example, I will give a simple scenario. The assertions will be like, for example, here, if you see my screen, it's like after Ankesh, it is Supriya, right? So I will write a condition saying that after Ankesh, the Supriya name should come. That kind of scenario I will write. I will use some system functions and I will write such a scenario. So it will observe in the simulation, it will see wherever the scenario is like after Anke Supriya, there it will, the assertion will pass, and wherever it is violating, the assertion will fail. So this is a very rich concept in the system Verilog, which it provides us to verify the design very thoroughly. Okay, there are some features like some low power feature. Most of the things there will be there where we specifically prefer assertions only to verify the design. So we will see further what are the different types of assertions we have, like immediate assertion, concurrent assertion. Why do we call immediate assertions? Because they will be evaluated at that particular clock edge only. And why do we have concurrent assertions? And if there are complex assertions, how do we combine the different sequences of the properties? All these things we will go through in this workshop. So today is basically the very basic class where we are trying to know what exactly we are trying to learn in this workshop in a little deeper way. Okay. So these, as I mentioned, we have different types of coverage, right? So I have just
Excuse
mentioned
me.
it, but today we will not go. Sorry.
Excuse me.
Yeah.
Sorry for interruption.
That's okay.
Can I assume this Assertion like a self-checking test bench?
Um, We can think so, because in the self-checking test bench is nothing but you are writing the, for example, the scoreboard logic which we have. We will be having a scoreboard. What will we do in the scoreboard? We'll be trying to compare the expected data and actual data, right? At the same thing, we will mention in the particular test case itself. You will be writing some kind of checker mechanism, right? Likewise, only this assertion also, but it has some different kind of things. Means we use sequences, properties, and this will be for the entire all the tests also. It will be applicable if we include these assertions in our top level. So like that, if the self-checking TB means only for that particular test, if you are trying to do, it will be applicable only for that particular test, right? But assertion, if you include that scenario in the top level, and wherever that kind of assertion, if you want to call in that particular test case, you can include it. Through that, you can verify it. So you can think it is a self-checking also, but we don't call it that way, but you can think, because the purpose is same, right?
Yeah, okay, thank you.
Yes. Yeah. So that's it for today's session. If you have any queries, you can let me know. So today I have just included a very basic intro. So from tomorrow we will see the different types of code coverage, and we will see some coding also from code coverage, and then we will go with the functional coverage. I will explain each and every, means from basic concept of functional coverage, because many of them doesn't know exactly what is functional coverage. So all those things also we'll cover, and what are the different types of bins. After code coverage and functional coverage is done, then we will go to assertions, and after the assertion is done, we will try to take up the different system Verilog UVM interview questions. And in between any of the questions on code coverage, on functional coverage, like how I have included here, right? These kind of questions will be there. Those things we will discuss. So this is the main agenda of this workshop. So anyone have any questions?
Ma'am, the question in this slide.
Yeah.
So these questions you'll answer in the subsequent classes,
Yeah, we
or
will. Actually,
are
I'll
these
make you
questions
answer
are asked?
basically in the subsequent classes. If still anyone is not getting it, I'll help you out.
I get it. I get it. And then we will have any practical writing sessions of with this bins and
Yes, we
I
will
mean
do
like
it.
a
We
project
will do it.
we have, right?
Yeah.
Okay, okay. And will you share this PPT of today's class?
Yeah, as Prashanti mentioned, we will share the
Yeah,
entire
we will
material
share,
at the end of
we
the.
will share the PPT
Yeah.
material, and we will share the remaining reference materials also. Okay?
Yeah. And any
Okay, okay.
assignments
Yeah,
also
yeah.
we will
Thank you.
plan and
Yeah,
we will
we'll
share
share
it.
the assignments we'll share from tomorrow.
Yeah,
Day after.
Mhm.
Okay, okay.
Meanwhile, you can
Okay,
go
okay.
to.
Yeah.
Okay, thank you. Thank you, ma'am.
Yeah.
Others, do you have any doubts? Devika, Omkar, Prajwal and Tamil Arsan. Sudha,
As of now, no doubts, ma'am.
have you understood the topic?
No doubts, ma'am. Yeah, yes.
Devika, have you understood the topic?
Yeah.
Okay.
Devika, can you say what is code coverage? As you are new to this, right? So if I hear from you, it's good.
Let them see first. They will go through the session
Okay,
first.
okay, fine. Yeah. Okay, from when we come to the next session, make sure that you just have a glance of the concepts which we have gone through today, so that we will have a first 5 minute session, what we have already discussed, and then we'll go further. Okay. Let's make our session more interactive because that will give us everyone good experience, right?
Yes, ma'am. Yes.
Yes.
Ma'am, 8 is the timing, right, for our everyday class?
Yeah.
Eight
8
Up
to
to what?
8
Up
to
to
9.
8 to 9:30. Today is the
9:30. Okay.
introduction session, right?
Okay.
So
Okay.
we
Yeah.
have
Thank.
closed quickly. So from
Okay.
tomorrow on,
Yeah.
two
Thank you.
sessions, mostly two sessions. If you have more doubts, we need to discuss, means we'll join for third session also. 2 sessions means 40 plus 40. Okay.
Okay. Cool.
Each
Cool, ma'am. Yeah.
session
Thank you.
duration 40 minutes. Okay.
Hello, ma'am. Hello, ma'am. I joined the session late. Can I get the recording of today's session?
Yeah, I will share you the whole recorded session. Okay. So you can go through that. In that, some other more concepts also given. So that will be more clear for basic understanding. All these workshop sessions we will provide you at the end of the workshop. If you miss any session, we will provide immediately. Okay.
So, ma'am, these
Is there any
recordings will
doubts?
be sent. Recordings will be sent on our email ID or on a WhatsApp group. Link will be there.
No, we'll share through email only.
Email ID. Okay.
Yes. We will
Thank you.
share you the link. You can access directly. You can send the access request so that you will get the sessions.
Okay, ma'am. Thank you.
Yeah. Others, is there any doubts? How is the session today? Any feedback from you?
Interactive. That's good interaction, ma'am.
Yeah,
Okay.
please provide any feedback, any one of you, so that we can, however, this is an introduction session. Next sessions we can plan that way.
Hi, madam.
Yeah.
This is Priya. I'm Shalu,
Okay.
sitting there. Yeah, madam, I request you, I want more practical examples to be,
Yes,
I mean,
Shalu, definitely.
yes,
See,
but
so first 2 days
especially,
we will cover starting from scratch onwards. Anyway, 4 days
yes,
is more enough for the coverage analysis. Okay. So first
yes,
2 days
madam.
will be scratch only because there are some undergraduate students also here. So
Yeah, yes, madam.
by end of the workshop, definitely we will provide you the very advanced topics also with the examples. Okay.
Madam, one request, madam.
Yeah, sure.
Hello? Can I,
Yeah.
can I tell?
Yeah,
Madam, my
please.
request to me, I see, madam, I'm really, I need to learn many things. So my request is, whatever topic concept you're explaining, I really want to know in the real time scenario more,
Yes.
example wise. That is
What are you
really,
doing currently? Are you working?
yes, madam, I'm working.
Okay.
Yeah,
Yeah,
I'm working.
we will discuss everything in the current scenario only. Okay,
Yes,
whatever
especially,
project we are
sorry,
doing.
madam, my humble request. Real time scenarios, it will be very good for us. And I hope, I mean, it will be it will be a very good thing for us to crack further interviews or to
Yes,
be in
yes.
a good idea to
For the
help us.
interview purpose only, we have launched the workshop. So
Yes,
mostly
yes,
we are
madam.
focusing on that. Okay.
Yeah,
Yeah.
I mean to say that examples should be like If we get in real time situations, like real time environment situations, it will be it will be helpful for us in a guidance way. And the interview way also, it should be helpful for us how to crack and how to give an intelligent
Yes,
and smart answer in this.
yes,
That's
yeah,
what my humble request, madam.
yes. Yeah, sure. Even if you don't request also, we'll do the same thing, okay?
Sorry, madam. Actually, I'm
Yeah.
so curious about this.
We
The way you are
already planned,
explaining.
right? We already planned the workshop. Even if you don't
Yeah.
request also, we understand from student side also how they will crack the workshop, what are the main important things they need to learn. So what are the strategies they need to learn. So definitely we'll
Yeah.
work on it. Okay.
Thank, thank you so much, madam. The way you explained me, the way everything went on is very good, and really, I'm really happy to go for further classes. That's the reason I mean, I'm keeping a word of my request from my end. Don't
Yeah,
mind,
sure.
madam.
No,
Okay,
no.
no problem. Okay. Okay, then
So, ma'am, we
everyone.
will have a session every day, 1 hour session.
Yeah, mostly actually at the registration time we'll told day by day, right? Alternate days, but mostly we'll schedule the regular sessions only. Maybe for 2 or 3 days we'll take 1 day gap. Okay, after 2 or 3 days for
So we have session
practice
tomorrow.
for assignment
Yeah,
practice.
if we plan any assignments, no, based on that we will see. If you are not taking a session, we will see that you will be occupied with some assignments. That way we will plan. Mostly, as Prashanti told, we'll do it every day. If it is not
Because even
feasible
if
at any
we
time,
because even if you schedule every day also, you are not getting the time to practice the assignment. Okay. So assignment practice also very important. So according to that, we will plan mostly every day only. Okay.
Thank you, ma'am.
Yeah. Okay, all. Thank you.
Ma'am, one last
Thank you,
question.
ma'am.
Sorry to interrupt. Sorry to interrupt.
yeah,
What is the duration of this course?
10
10
days.
days.
10 days, na? Okay. And these workshops, I mean, sorry, the assignments will be, are needed to be implemented on paper or on a tool?
We will share through WhatsApp. Okay, so mostly programming only. You need to
Okay.
submit through Excel sheet. Okay, you can practice the program and you can paste the program in the Zoom in the EDA link. Okay, that link you can
Okay.
submit in the Excel sheet. Okay,
I got it. I got it. Thank you. Thank you, ma'am.
okay, okay. Then thank you all.
Thank you, ma'am.
Thank you all.
Thank you, ma'am.
We'll meet tomorrow.
Hello,
Yes, Anil,
I'm audible?
yeah, you are audible.
Okay, okay, thank you.
Let us wait for 2 more minutes and then we will start the session. Let us start the session at 9:05. We will wait for some 2 minutes. Meanwhile, anyone voluntarily can unmute yourself and tell me what is core coverage.
Percentage of RTL or the lines of RTL executed or covered.
Okay. Other than Anikesh, can anyone?
Code coverage means how much of code is covered they show. Mostly the code coverage given by the RTL. I mean simulator they give that.
Yes. Okay. And what is functional coverage?
Functional coverage means like how much of functionality is covered while writing your test bench using coverage.
Okay. So can we
It's
track
like a functional coverage means in that
failed test
they
case?
can lines are covered like how much. Hello.
Yeah, can we track the functional coverage for the failed test cases?
No.
Okay. I think we are good to go to start with today's session. We have enough people. And anyone have any doubts related to the previous session?
As of now, no, ma'am.
Okay. Fine, then let us start with today's session. It's almost 9:06. So today, the major focus will be the functional coverage and the code coverage. What is, I can say, the in-depth knowledge. Yesterday we just have saw the introduction, right? So today we will go further. So in code coverage, as we have already discussed, in code coverage there are different types. One is block coverage, and then it is just a minute. It is
Hello.
yes.
Ma'am, actually, today I have to travel at this time, so I'll not be able to attend the entire session. Will can I get the recording of
Yes,
the session?
we will do that.
Okay, okay.
Yeah.
Thank you.
Yes. So in code coverage, we have different types. That is statement coverage, line coverage, statement or line coverage, one and the same, path coverage, and then block coverage, and then toggle coverage and FSM coverage. So we will cover all this in the code coverage part, and then we'll go to the functional coverage. Okay, so as Anikesh and someone else also, Anil Kumar, they all have explained what is code coverage and functional coverage from the knowledge of the previous session. So let us go further. What are the different types of coverage? So statement or line coverage is nothing but, as we all know that in code coverage is nothing but the number of how well our design is exercised, right? So the design is exercised in a sense, then again we'll be having the different types of coverage, right? Means like the line coverage, block coverage. So line coverage is nothing but each line. Means, for example, this is a piece of code. If all the lines are covered, if all the statements are covered in this snippet, it means that the statement or the line coverage will be 100%. Usually, as the code coverage goal is to have a 100% right. So it means the statement coverage should be definitely targeted as a 100% itself, because it will ensure that every line is getting covered with respect to the design. Okay. So is it clear, right? The statement or line coverage?
Ma'am, in the design or test bench,
Design.
every line will be covered.
Design.
Only design.
Yeah. So test bench, we will try to give the stimulus in order to exercise the design. So we will always, we are verifying the design, right? Why are we doing this coverage closure and all? It means to verify our design thoroughly. So these are the different metrics to track the progress of our verification, right? So in that case, we have to concentrate the lines in the design, not in the test bench. Okay. So
Okay.
then it is path coverage. In path coverage, we will be having the different paths, for example. For example, this is the code. In this, we have if block, right? In the if block, again, we have something like sub statements. That is, we are writing a B is equal to E or E is equal to P. That is going inside and it is entering into some case block. So now with this, we will have one path here and the second path will be this and the third path will be this and fourth path, fifth path, sixth path, like this. So we have 6 different paths. Can everyone please mute yourself? Shiva, I think you forgot to mute. Yes. So now we have n different paths here. So the path coverage is mainly focusing on means like and you have done the branch coverage, then why do we need path coverage is the question now. The path coverage will also give the sequence of the operations. In branch coverage, you will only get one sequence, right? But here it is like if this is going this way and then in KC it is going to the path 1. So it means this is one bin, for example. The second one is the path 2. Did we cover this path? Did we cover this path? This way the analysis is done in the path coverage. So in order to cover even this kind of scenarios, the path coverage is needed. As it is very complex, right, to cover all the scenarios. So the path coverage, doing the analysis also is not that easy as statement or line coverage. Because in statement or line coverage, if that particular line is getting executed, that is enough. But in the path coverage, it's not so. It has to come into this if block and this series of the statements has to be executed in the else part of the things also has to be executed. So based on the scenario, it will vary. So it is little complex in the path coverage. Okay. And next we will.
Ma'am.
Yes, yes.
In the example already you said not line coverage, right?
Yes.
In that line coverage, that if else statements are also covered, right?
Yeah.
A piece of code contains some lines are 10 or 15 lines. All lines are covered. Why you are using again like path coverage, right? All in the path coverage also they considered if else statements. In the line coverage also they considered, right?
Yes, yes.
Yeah, why you are using path coverage? And one more question, you said not branch coverage, right?
Yeah.
Yeah, may I know about it?
Yes, yes. So as I already said, we have different types of coverages. Why? That is because here in the path coverage, if you see in the description also, the path coverage is considered to be more efficient than branch coverage. It means if you see the branch coverage, it means nothing but like if suppose if and begin end. In this block, we have some statements to be covered. Okay, so through this, you understood that this branch is executed. But if I have a scenario where I want to check whether in the sequence of operations, means first if the parity is odd, then only it will go to the statement. And then it is going, we have some sub block for suppose. Here we don't have as such, we will be having some sub block. So it has to, I want to track basically that path, means it is the parity is odd and we need to compute the parity. And then again, I want to check what is the sub condition in this compute parity, all that. So in that way, this path coverage will give us more efficiency. It all depends on the requirement. If my requirement is such a way in that scenario based requirement is set, then I will choose the path coverage more weightage. I will check for the path coverage. If I don't have any such requirement, I just want to see the coverage, then I will go with the simple statement or line coverage. So it all depends on the requirement. Got it?
Branch coverage as well as line coverage both are same.
No. Line coverage and statement coverage are same. Branch coverage means it is one block. Either it should be if block or it should be else block or it should be some begin end block or it should be some always block. Any of the bunch of statements basically comes under block coverage. Okay. So next we
Okay,
will, yeah.
you said branch coverage as well as path coverage both are same?
No, path coverage
No.
is different. Okay. So path coverage is the different paths, means the sequence of the scenarios I have mentioned, right? And line or statement coverage means one and the same. And then it comes to the block coverage. The block coverage is nothing but the group of the statements. Okay. So if you see here, we have an always block. So we have one if block, we have an else block. So in the always block, if it is covered means there will be one bin hit. Means for the, we don't call in code coverage as bins. I'm just saying one entity is hit. So block coverage labeling will be there. That particular thing will get hit. So we will see the amount of coverage that has been calculated by the simulator. That's how we do. And then we have something called toggle coverage. In toggle coverage, yesterday also we have already saw, right? It means from any variable is there in the toggle coverage that has to be transitioned from either from 0 to 1 or 1 to 0 or x to z, z to x, everything possible way it can happen. But for us, the important thing will be from 0 to 1 or 1 to 0. Okay. And the toggle coverage does not consider the zero delay glitches. So do anyone know what are glitches?
Yeah, ma'am. Glitches, I know.
Yeah, what is a glitch?
Because glitch means when you send the data in the passage clock or before the passage clock or negate clock, if it is get the data, it will be glitches in that. Maybe it will be in the flip flops. It will be occurred.
No, it's not occurring flip-flops, it occurs in latches because
Sorry, latches.
latches work on the sensitive edge, right? They are edge sensitive. So there could be a more chances of getting glitches. So basically glitches means it should be, there is some short pulse. Even within the time period itself, we will be getting some short pulse. So for those things will not be considered for the toggle coverage. So this information will be mostly if you work on the GLS gate level simulations, there it will be useful for you. So in this, likewise, you will get the report from the code coverage. This is a snippet of a cadence tool. So here, if you see, we have block coverage, toggle coverage, FSM coverage, all that, right? So here, if you see the toggle coverage, there is something called 71.43%. Means here it is like overall 10 out of 14. Means of the 14 combinations, only 10 are hit. That's why this is the percentage calculation. Means for example, you can think like if the variable is suppose 2 down, just it's a bit variable as a. Okay, so it means it has a possibility of either from 0 to 1 or from 1 to 0. But if there is a possibility of like there could be vectors, right? Means we can have a higher bit of the variables also. Like we have something like 3 down to 0, a, like that we have. In that way, what it will do is it will check k of 0. A of 0 is transitioning from 0 to 1 or 1 to 0. That will be considered as one possibility. And then it will see A of 1. Likewise, it will check for A of 2. Likewise, it will check for A of 2 and A of 3, like that. 3 down to 0 means how many combinations? 2 power 4, right? Means you will be having from 0 to 15 combinations. So it will see for A of 0, A of 1, A of 2, likewise up to A of 15, and it will club the entire thing and then it will give the report. So likewise, the toggle things are generated. Okay, is it clear? The toggle coverage?
How it will be generated? No? You guys, just we can write A of 0, A of 1, A of top, A of 15. Is it okay with that?
Basically, you will just declare the variable and you will on the code coverage to the simulator. The code coverage simulator will give us this report, right? And when you see the each variable, for example, you click this toggle and now you found that there are 10 out of 14, right? So it means you will see that particular variable which is not getting toggled. So then you will also see, right, A of 0 and A of, there could be, for example, we have A variable and it A of 0 and A of 1 are not covered. Everything else is getting toggled. So at this point, you will understand this what I'm explaining at the industry level, how do we check? So the A of 0 and A of 1 are not covered, right? So then you will go into the design and see why this A of 0 and A of 1 are not covered. They're either they could be tied to 0 or they could be not used. Means, for example, we in I square C we are working for suppose in a protocol, and we are trying to exercise a different addressing mode, 10-bit addressing mode, 7-bit addressing mode. So the 10-bit addressing mode we are not using at all. We are only using the 7-bit addressing mode. So if you are using only the 7-bit addressing mode, the 7-bit the 10-bit addressing mode variable will not toggle, right? So that way you have to understand, okay, this specific, we are not using this feature, that's why this is not getting toggled. So you have to check with the designer what your conclusion you have done is right or not. And based on that, you will create an exclusion list where you will include that only 0 and 1 are not getting toggled. That is because we have reasons. You have to mention the reason also, and then only you have to add that particular variable in the exclusion list. Through that, the designer will accept that, okay, these are the valid reasons. Then only you can put them in the exclusion list. Then you can see that here the toggle will be getting covered because you will put that in exclusion list, right? So your code coverage number will increase. So first, initially, you have to give the simulator. You have to observe what are there, what is the report, and whichever are 100%, you need, or they are already covered. Which are not covered, those things you have to analyze this way and talk to the designer, and then you have to take the necessary course of action. So that's how the entire process goes in an industry for the toggle coverage or any of the coverage as suppose. But for toggle coverage, I got a chance to explain, so I'm telling you here. Is it clear?
Out of 14, 10 will be covered. How you know that remaining, what are the remaining 4 variables are not covered? 4 bins are not covered.
Yeah, in
How
the,
do we know that the particular bins, 4 bins only not covered? How do you know that? How do you know?
yeah. So you can click on this in the, if you have a real-time tool, there you can click on that particular toggle, and then you will get the information for which variables it is not for which variables it is not covered. So there you will be seeing, for example, U of 0 as here as 0%. So it means this is not covered. A of 1 is not covered. So whichever are not covered, that you will see the variable, why we are using this variable in our design. So what is the purpose of the this variable in the design? Then you will go and see, for example, we are using an address of 31 down to 0. So here,
One more question, ma'am. If you are using 32-bit, right?
yeah.
At that time, if you want to cover all the bins, up to 32-bit means like how much, ma'am? 6 to 535, right?
Yeah.
Yeah. Is it possible to check that all the 6 to 535 bins every time?
We will not check that, right? Only the simulator will check that.
Yeah. That simulator will check.
Yeah.
Again, how many bins are covered? If for suppose out of 62,535, only 40,000 will covered, remaining 20,000 which is not covered. Is it possible to check what 20,000 it will be not covered?
See, there could be a reason it will directly show us, like for example, 32-bit data is there, it is not toggling. That is because maybe half of the, for example, if we are considering it as some aligned address or something, okay. In that we can write a reason that only the lower bits are not used. We can understand from the design, like why these bits are not covered. So based on that, we can think that these lower bits are not covered. So you can directly include that 16 down to 0 as lower bits if we are not using it or there could be something like if it is aligned address, modulus 4 of 0, whatever is there, those only will be covered, others will not be covered. So for that you need to put a reason, and then you have to include that number of bits in the exclusion list. Likewise you have to do it. It's not a hard
So in,
that everything has to be covered, right? Yes, Sudha.
yeah. So in real time, like what will be the tool to check this?
Like a VCS based on that vendors are based on the clients. If you are working the cadence or something, we have to use the VCS or synopsis somewhere. Based on the vendors, we have to use.
Okay.
Thank you, Anil, for answering. Sudha, that's true. It all depends which tool we get.
Yeah, okay.
This is the cadence tool snippet which I have taken, but in every tool you will have a clear report. Based on that, you can work. That's not just it will be user comfortable only. Just by seeing that, you will understand. You can just go on the flow. Okay. So next we will go through the FSM coverage. In FSM coverage, the two things are there. One is that all the states are covered or not, and the other thing is that the transition is done or not. For example, here we have in FSM state ideal, setup, access, and wait, right? So there are 4 states basically. So first part will be like whether ideal state has hit at any one at least once or not, and setup, access, wait, all this that is one kind of coverage in the FSM, one aspect. The other aspect is from ideal to setup it has gone or not, for ideal to access. There could be a case, right? There is not necessary that ideal to wait it should go. So in that case, we can include that part of the scenario in the exclusion, because we don't have such scenario in the specification or anywhere where, or we don't have such requirement at all that ideal should go to the wait. So in that case, you can write a proper reason for that, and then you can add that into an exclusion. So when you give it to the tool will not do anything. Tool is a robot, right? So it will just check that whether it is all the combinations are happening or not. So as a verification engineer, we should put our thought to understand as we know the design. As you know the design, I know the design. So I will think that why there is no requirement at all to go from ideal to wait. So why is it showing this? In that case, you have to exclude it by giving a proper reason. So that's how any verification engineer has to think. So before doing any coverage plan, in most of the industry, first they will ask you if you are assigned with some coverage task, for suppose, they will ask you to create a coverage plan. How will you create the coverage plan is first you will understand the entire design or the specifications. Through that, you will have a rough idea. Initially, you will have a rough idea for a coverage plan. Later on, you keep on increasing that based on your understanding. Your understanding will keep on increasing, right, by working on the project further. So then you have to update your coverage plan. Initially, you have to create a rough coverage plan. Based on the understanding, you have to update that. Okay, here this requirement is not there, so we don't need this. Or there could be some special cases. You may think that this is some priority feature you would have observed in the test plan. Everyone is focusing on that. Then you have to note down even your coverage plan note, right? Like this thing I need to sample. So this thing I need to cover. This scenario should be covered at any cost. So if you note that way, you will not miss the important things. So that's how the coverage plan is done. So this is about the code coverage. Next, we'll go to functional coverage. Before that, anyone have any doubts?
So how can we write this code coverage? Like automatically tool will detect this?
Yes. Automatically tool will give the code coverage report. Based on the code coverage report, if you want to do any changes, for example, I have explained, right, in the toggle coverage, like that analysis we need to do, and we need to add the exclusions. Things. The other way is, for example, everything is proper, means from the design way also it is saying that it should be covered. Everything has to be done. In that case, you have to go to your test bench or the stimulus. You need to improve your stimulus and make sure that that particular piece of code is getting covered. For example, you didn't create a stimulus at all. So in a scenario where, for example, we will see this FSM only. Here, this is an FSM, right? In the code coverage, if you were thinking that you didn't, in your test bench, you didn't provide a stimulus at all, where from the reset condition, it has to go to the next condition. Means at the reset condition, it will be in ideal state. If the P select is high, then only it will go to the setup state. For example, I didn't give this P select high at any point of time in my stimulus. So it will not go into this piece of code, right? So this will not get covered. So that's how you need to analyze, and you have to improve your stimulus. So these are the two ways where you can improve your code coverage.
Ma'am, can you show one demo of any of these coverage in the tool, how to do and how to run, how we will get that?
Here for the code coverage, I don't have any means like a tool because in the EDA we cannot have the demo of the code coverage, but functional coverage we can do that. So that is why I have given this snippet of the report. So this is how it looks in any of the tools, like how the coverage is done, all that. But at this short span, in this 10 days of the span, I cannot show the entire how it will work and all. But with this much of knowledge, at anywhere you can drive working on it. But for functional coverage, we will practically work on some codes and see how the bins are hitting all that. Okay.
Okay, thank you.
Yeah. So then this is all about the code coverage, different types of code coverage. And then we will see about the functional coverage. Why the functional coverage has gained more significance means there is this kind of scenario also, right? We can write, for suppose I have 10 features, I will write 10 test cases. With that, all the functionalities are, if my 10 test cases are passing, so I can state that, okay, my verification is done, right? Why should we have, why should we need to collect the coverage only to verify the design is functionally correct or not through functional coverage itself? I can do this way, right? Writing, I have 10 features, so I will write 10 test cases to cover all the functionalities. So then why do we need functional coverage? Can anyone answer that? Sudha, will you give a try? Hello.
So,
We have the
functional
we are
coverage,
writing the test cases for the functional coverage means how much
it is
of the
used to verify the
functionality will be
quality of.
covered.
Anil, can you just mute yourself? After Sudha, you can tell. Okay. Yeah, Sudha, go ahead.
So functional coverage, it is used to measure the quality of verification.
Yeah. We can even do this way, right? We for suppose you have 10 features, you can write 10 test cases. So why do we need the functional coverage? You can say that the functional coverage is quality of design, right? Means how many features are exercised. That information functional coverage will give. But you can even do this way, right? You can just execute all 10 test cases and you can say that all 10 features are verified. Why do we need to choose?
Like what if our test cases are more? So it will be very difficult for us to verify all the test cases at that time.
It's partly correct. Anil, you want to say something?
No.
Okay. So in functional coverage, what is the main advantage is that, so we all know that there are two types of verification. One is direct verification, other one is constraint random verification. If suppose anyone doesn't know it, let me tell you about that. That is directed verification means you are writing a particular direct test case. Means you have 10 features, you will write 10 test cases. But with that, there could be a situation where you will be missing some corner test cases. For that, we are having something called constraint random verification. But suppose there is something called like data bits. If I say, we have some feature called differential data bits. Means the data bits can have 8 data bits, 10 data bits, 15 data bits like that. Okay. In that case, what I will do, I will not write like one test case to test the data bits as 5 and other test case to check the data bits are 10. Like that, I will not do it, right? What will I do? I will create a random variable for data bits in my base test or somewhere and or in a global config, and then I will randomize this data bits, right? So when I randomize this data bits, each time it runs, it will have a new seed value. So when I have a new seed value, it means every time it will generate differential database. So same test case I will use by using a constraint random verification. Each time it will generate a different database. First time it might generate 8 database, second time 10, second time third time 12, like that. So collectively we can have this functional coverage also. So we understood directed verification, we understood constrained random verification, but how is this related to functional coverage? So when it is randomized like this, so if you enable the functional coverage for that particular number of test cases, so with a single test case only, in functional coverage, I will write a bin for data bits. And I will write like the data bins, I will write some bin like the bin should be one is 8, the other is 10, the other is 12. So this way what I will understand is by running this functional coverage, okay, as we have done the randomization, so through this data bits cover 8, 10 and 12 are covered. If suppose any of the bin is not covered, it means that I need to increase the count of the regression so that it will track any of these bits. So through this, the functional coverage also we can track that how many features are not exercised. As Sudha said, if there are so many test cases, I can't keep on writing each test case for the each feature, right? So that's why we got into this constraint random verification, and that's where the functional coverage has got it more significant than the code coverage in covering the this how to effectively verify the design. So this is a whole idea for the functional coverage. Okay. So then before, I think we need to join in next session. So before that, anyone have any queries, we can discuss. Fine. So in the functional coverage, system Verilog basically provides two ways to check the functional verification of the design. One is through cover group. So the cover group, which is used from the information from the transactor, monitor, or the checker, right? From these, the information is collected and is sent to the coverage collector. So either we can have a different coverage class where we can have the different cover groups, cover bins, everything, etc. Right? And the other way is the assertion coverage. The assertion coverage is nothing but yesterday, as in the intro I have mentioned, right? This is some temporal language to get the whether the kind of scenario which you are trying to target, the scenario you will write in the system assertion language. Means, for example, one sequence has to be coming after 2 clock cycles. So you will write something like this sequence 1 should come after 2 clock cycles, means we have to provide this 2 hash delay after 2 clock cycles, the S2 has to come. Likewise, if I mention. So it means it will say that S1 is high after 2 clock cycle, S2 should be high. So this kind of language we will write in an assertion to cover the functional verification. Okay. So we will go through that further. Guys, shall we join the same session once again? Just leave the session and join the session once again, because the session will end in some 2 minutes.
Okay, same link.
Yeah, same link.
Okay. In the functional coverage, so now we understood what is code coverage, what are the different types of code coverage, and in functional coverage, why exactly the functional coverage has got so much significance in the verification. So all these things we have gone through, right? So now we will see functional coverage, what are the things which we need to understand in order to create a proper Okay. Okay, then let's go through this. So in functional coverage, we have something called cover group, which is nothing but like how we will have module and module, program and program. Like this, we have some program block, module block like that, right?
In the same way, we have cover group and end group will be having. So this cover group will have all the coverage model specification, whatever required models coverage model is it, that we will be having inside this cover group. So you will be having a doubt like this cover group, where and all we can use it, means where and all we can write that. So inside a program you can write, inside a class you can write, and inside interface or any module you can enclose your cover group. So in cover group, what all things again we'll be having, as like in class we have different properties, right? In that way, in cover group, what all we have? We have some coverage points we have. So the coverage points we can have, like it could be the cross coverage between the coverage points, anything we can have. So in the coverage, we also have something like clocking event. So we have a cover group. Then when should we trigger this cover group exactly? So that event we can give through the clocking event in the coverage group. If you are not providing that clocking event, then we have to sample that particular cover group at some instance. So we will see all this in detail. Don't worry. It is, as it is new to you, maybe it will be overhead, but we will see the practical examples when it won't be that much overhead to any of you. Okay. And then we'll be having some coverage options, and then we'll be having something like optional formal arguments. So all this will be having in a cover group basically. And then we will see the syntax of a cover group. So as I already mentioned, we'll be having something like cover group. Here you need to give the coverage model name. Means, for example, you are giving some cover group for monitoring some I2C bus speed. So you can give that. Or always you have to prefer the cover group names as meaningful so that everyone will understand. For example, you are doing the coverage for spy. So you can mention like spy CG, spy underscore CG. So with that, the spy, this is for spy protocol, and the CG means the cover group as a short form. Everyone will be using that. So I already told that there will be having some clocking event, right? So means the cover group name at the clocking event. Clocking event means either it should be a positive clock or negative clock or whatever it is. So at that point, this cover group will trigger likewise. And then, sorry. And then we'll be also having in a cover group, we can put some list of arguments. So all this, when we try some practical examples, you will understand, but it shouldn't be very new to you, right? When you try some practical examples, so that's why we are covering the basic syntax for that. Okay. So now let's see once more what all exactly a coverage file will have. So for example, I have declared two variables. One is address of 1 down to 0 and the data is of 7 down to 0. This is a width. So here I have declared one cover group. As I said, like module and end module, we will be having some cover group and end group. So the cover group, I have taken the name as CG here at the rate of POSH clock. So this POSH clock is nothing but the clocking event. Okay. So then inside this cover group, I have taken two cover points. So this A column and B column, these are nothing but the labels. So if you doesn't provide any label, then the tool will provide its own label of some, it won't be meaningful if it provides by the tool, because you will not understand what exactly this cover group is, cover point is while debugging. So it is always recommended to give the labels, so that if you give the label while debugging, if you see some the label this is not covered, then directly you can come to the code and you can find out like, okay, this is the thing which I am missing, so I have to cover this, we have to do some analysis. That's how you can start, right? So always it is recommended to have the labels. So then I am declaring a cover point as address and then cover point as data. Here I am not providing any bins, nothing. So it's just a simple syntax. Okay. And like how we create a class, right? We will take an instance of the class and we create it, right? In the same way, we need to do with the cover group as well. So with the cover group name, and this is the cover group instance name. So just by writing this way, this COV is my instance name. Why do we create an object anywhere you want to access further, right? Then you need this cover group, right? That's why you will write CG COV as new, and then using this instance, you will sample it. So COV.sample. So this is the major things you should know. If you get some coverage file also, you will be finding all this. So you should know what is doing what. So even though you are not writing a coverage file, but anyone giving you a coverage file also, you should be able to analyze, right? So for that, you should have at least this much minimal knowledge. Then you will, based on that different specification and all, you will go on the flow. Okay. Is it clear so far?
Yes, yes.
So can anyone say, what can I ask? What is the clocking event at the cover group?
Postage to
Okay. And can we have, how many cover points can we have in a cover group?
2
But
address data.
it is two. But you can have n number of cover groups in cover points in a cover group. Okay. So that
If
is
you are not using sample, can we create the cover group? Can we access the cover group if not sample?
sorry.
If you are not using sample, can we access the cover points?
No, after writing all the cover points, if you use this cover dot sample, then only your coverage will get triggered. Means whatever cover points which we have written.
Okay.
Got it, right? So then, so that's the next question. Like, what is a cover point basically? A cover point is nothing but a variable that has to be covered or sampled through the cover group. So, what are things you want to cover? For example, we have saw one example right about the data bits. For example, I want to cover the data bits. So, it means that I have to mention the cover point as data bits, and I have to give which all data bits I want to cover. What are the differential data bits I want to cover? All this information you will find with the cover point. So here it is like how many cover points a cover group can have. It could be n number. There has no limit for that. So and again we have a cover point. So now I set the data bits as a cover point. So in the data bits as a cover point, how many things we can have like a bins over there? That is also n number. If you are not mentioning any bins, it means that it will take by itself by tool. We will cover that further. But for now, you can think that cover point can have any number of bins and a cover group can have any number of cover points. So this should be clear for everyone. Okay. So in the cover points also, we have again 3 different types of cover points. And that is one is the item functional cover points. That means so if I want to cover some variable a with I will give some individual numbers. The a value should be covered with 4, then 5, then 10, or some range also you can give like 30 to 40 like this. So now this will cover only the individual items. So this item will be having only these things. If they are covered, it means that it will give 100%. Means a value should be getting 4 ones, 5 ones, 10 ones, and within 30 to 40 range should be also be covered. In that case, the cover point, this coverage is hit. So this is one way. What is a cross functional cover point is, for example, we have one more cover point B saying that I want something like 2 and 20. So now I have 2 cover points. So now if I want to do the coverage very efficiently, then what I will do is cross of A and B. So with this, what will happen is it will do the probability checking like 4 and 2. A value should be 4 and B value should be 2. This is one scenario. And the A value should be 4 and B value should be 20. This is one scenario. Then A value should be 5 and B value should be 2 and B value should be 20 when A is 5. So this how scenario, if you want to do it manually, how tough it is. So the system Verilog in the functional coverage, it provides this mechanism just by writing a single line cross of A comma B. So this is very efficient, right? So this is one of the cross functional cover point. The other one is transitional cover point. That means I can write something like if for suppose a value is there and a value I will write something like 4 after transition you will be having 20. So my scenario is like a should be getting a value 4 and after that as soon as the 4 is done the 20 should come. In this way, this is called something like transition. Or again, I will write like first I want to, there is a scenario, first I want to check the standard speed is working or not. So first I will check for standard and then if standard has no issues, then I want to check for fast plus. This is my scenario. So in that way, what I will write, the standard transition after that, the fast, then after that FS, fast speed plus. Likewise, I can create a scenarios based on your requirement. So the functional coverage has provided us these many facilities. It's up to us how efficiently we use it and what is our requirement. Okay, is it clear so far? Hello.
It's a syntax of transitional cover points. Can you write it?
Sorry.
That like transitional cover point syntax. You write the formula like that.
Yeah.
Can you write once again?
That we will see in the practical coding. This is just for an information like. So like some implication it will be and after that it will be for example 10 and then it will be 20 like this. We will cover one practical code for all this so that it will be very clear for everyone. Just this is our theoretical gesture to understand clearly what it is, okay. Okay. So then we will see further. So we have covered so far what are the different, what are the things we have in functional coverage, right? So I want to, there are some experience standards are also there, right? So all the basics will might bore them also. So that's why I have picked some industry specific guidelines for functional coverage. So how your functional coverage should be basically. So your test plan should be in such a way that it is covering all the functionalities. So that is first step. And the second step is like, as I told you that based on your test plan and the RS, you have to create a rough coverage plan initially. For everyone, the coverage plan, it won't be matured at the first stage itself. First, you will create a rough plan and based on your understanding, you keep on increasing the level of the coverage plan. And your test bench environment should be having a mechanism like you can enable the coverage or disable the coverage. That is because why do we need this feature of enabling and disabling the coverages? Initially, at the first stage of the verification, for suppose I have written all the test cases and the test cases are some are passing and some are failing. So at that point, if I enable my coverage, so it will be overhead, right? Already you are not clear with the test cases, or you have some so many bugs. So first you need to clear all the bugs. So at that point, you will disable the coverage, and slowly, if you see that the bug rate is decreasing, at that point you will slowly start this coverage enabling, so that you can parallelly work on both. So for the test cases which are passing, for those you can track the information of the coverage and so on, you can continue with the work. So that's why your environment should be flexible enough to enable and disable the coverage. Okay. So that is what here it is mentioned, like we should enable the functional coverage at the beginning of the verification. We shouldn't actually. I by mistakenly told we should. So with this is the basic guidelines anyone should know as a ASIC verification engineer, when to enable the coverage and when exactly you should start the coverage analysis, all this. Okay. Any doubts regarding this? Okay. So I already told this, right? The functional coverage plan should be updated. Initially, it will be very rough, and then slowly, based on your understanding, you have to improve your coverage plan. So, and the most recommended thing is the cover group and the cover points, whatever names, not only as cover group, cover points, any design or any verification you are doing, any test case you are developing, everywhere the test name should be very meaningful. Means anyone, if I come and see your test case, I should understand, okay, this test is for write and read. This test is for read and write. So likewise, your test name should specify as what exactly this test is doing. So that will create an impression on you, like how sensible you are, writing some comments. All these things we have to use while writing a test case or any cover group or any cover points. So this will also help you while debugging also. Okay, this cover bin is not covered. I know because this name itself is telling that the differential database means there are it is not covering the different database. Then you will go and check in the bin. Okay, what are the things are covering, what are not covering. Like that you can analyze. Okay. And then this we have discussed in our introduction session only that the coverage cannot be captured on the failing simulations. Only for passing simulations we will be capturing the coverage. Okay, and there could be a scenario your tests keep on exercising the same logic, and it is not focusing on the some dead codes. So those things also we have to keep in your mind, like which are the dead codes, why it is going to the dead code. Means something like default condition is there, it is never hitting that condition because either of the one of the options in your case statements are getting covered. So the default statement is not getting covered. So that all these things you can keep in your mind while creating your coverage file. Okay. So then comes up to coverage bins. As I said, we have a cover group. Inside cover group, we have cover points. Inside cover points, we have coverage bins, right? So what are these bins are necessary for us? As we saw already, like the bins are used to collect the coverage information, right? For a particular feature, what are the things you want to cover specifically that you will mention in the bins. So as I've already shown you, like in bins, we can either give a single value or you can give in a range also. So the bins can be automated or you can explicitly write the bins also. So how is that? All that we will see. So today we will see only two bins. One is implicit bins and explicit bins. We have so other things also. If I tell everything on the same day, it will be very confusing to everyone, right? So that's why we will stop with the implicit bins and explicit bins, and then later tomorrow we will cover all the practical aspects of the functional coverage and everything like transition bins, cross coverage. All this we will try to execute through code and analyze the outputs. Okay. So in implicit means it's nothing but here if you see, I said, right, we can enclose the cover group inside a class module anywhere. So here in this example, we are enclosing the cover group in a class and end class. So here we have something like address, which is of 2 down to 0 width. So in the cover group here, as I mentioned, we need to put labels so that here the label is C1. In the cover point, we are writing address. Okay. So here I'm not specifying any bins. It means the implicit bins. So if you don't specify any bins, the tool will automatically generate the bins. How will it generate? So as it is 2 down to 0, right? Means 3-bit. So 3-bit means 2. You will be having how many combinations, total combinations. Based on that, the number of bins will be generated. So it is 2 down to 0 means 2 power 3. So total 8 bits. 8 possibilities are there. That is 0 to 7. So all these things will be generated for address. It will check like address is 0 or not, address is 1 or not, address is 2 or not. So based on that, if any of the bins are missing, it will reduce the coverage thing and it will give us a result. So that's how it is. Here we have created the coverage also. This cover group, I told, right, we need to create it. And then we need to sample it. Okay. So this is the implicit bins. And then we have something like explicit bins. Means in implicit bins, you will not give anything, just you will declare like this. So based on the possibilities, it will itself generate. Then it is explicit bins means I will give by myself. I have such requirement where I have to cover only these. Okay. For example, bins A. is 0 down to 3. I have given it here like it should cover 0, 1, 2 and 3. All these things it has to cover. I am giving a range here, okay? And the other one is B. Like this, if I give it is subscript as empty, no, that is also automated bin it will take. So now it will take B of 1 should be 4, B of 2 should be 5. So like that it will take, okay? Based on the range which we give and based on the subscript it will take. If I mention some subscript, then it will check like C of 2, 1 is 6 or not, then C of 2 is 7, 8, like that it will take, okay? So these are the different kinds of bins which we have. So we will cover further in next sessions in the practical coding also. So far any doubts? We will summarize once what all we have covered today and then we will wind up the session. Is everyone there?
Yes, yes.
Yeah.
Yes, ma'am.
Okay, let's.
So, ma'am, in real time, we will use explicit bins.
No,
in
it
real time.
depends. For example, I have a requirement here address. If we see implicit bins only, address I is there. I don't have any specific requirement that address value should be having some value like 30 or I should have some value like 20. I don't have any such specific requirement. Then I will simply declare cover pointer's address. With this, it will cover all the possibilities. Once after the possibilities are done, then I will check the report. If I don't have any specific requirement, I should make sure that it covers all the possibilities. Means I need to increase the randomization count. With that, it will cover all the possibilities. That way it will work. It's even in industry level also we use implicit bins, explicit bins, everything we use. Just that about your requirement, it varies which thing you have to choose.
Yeah, okay.
Okay. What about others? I can see Sudha, Amit, not Amit, Aditya and Anikesh. These people are active. What about others? Do you have any questions? Vishali, is it clear?
Oh, ma'am.
Everything? Sorry, someone. You can go ahead. Someone has unmuted, right? Hello. So can we wind up the session or anyone has any doubts?
No doubt.
Okay. So let me summarize. Actually, yesterday one of the candidates have asked to summarize at the end of the session. So let me summarize for you all. Like today we have saw the different types of code coverage. In code coverage, what exactly we have saw is the statement coverage, path coverage, then block coverage, then FSM coverage. All this we have covered in the code coverage. And then we saw some snippet of the code coverage, how exactly at the industry level we have the snippet. So that we have saw. And then why do we need functional coverage when we had a option of just creating a test cases for particular feature, but why the functional coverage has got its more significance? What is directed verification we saw, and what is a constraint random verification? How the coverage is related to the constraint random verification? All this we saw, and then what are the things which we have in the functional coverage? Means if we want to write a coverage file, what exactly some idea we should have, like cover group, what are cover points we saw, and then what are the coverage bins? What are the different types of bins we have? And what are the industry specific guidelines to create a functional coverage? So all these things we have gone through in today's session. So tomorrow we'll go through more about the functional coverage practical codes. So if you have any questions, you can even post in the group or you can ask right now. Otherwise, we will wind up the session for today. Okay. How did you all like the session? Did you like the session or do you need any improvements?
Like
So far, it's good, ma'am. Like as we are going from a basics, like it is good. But maybe when we go even for like further classes,
Yeah.
like we can have more practical and
Yeah.
real time.
Tomorrow we will concentrate on the functional coverage coding part only. So for
Yeah,
today we have just covered a theory part and all. Okay.
yeah.
Mm. What about others? I can hear from Sudha, Anil, but others don't interact. I prefer the session to be interactive. This that will be more beneficial to you only, not to me. Like today, Anil has asked some two questions, which got me to tell different industry related things also. If you guys ask questions, it is beneficial to you, not to me. Right? Okay, then let us end the session for today.
Okay, madam.
Okay.